children, hope everyone is fine. We will today study the topic on magnetism, and we will learn about magnet, types of magnet, properties of a magnet, magnetic compass, maglev train, handling of magnets and uses of magnets. So let us begin with the magnet. Long ago, in ancient Greece, there lived a shepherd named Magnes. He used to take his herd of sheep to the nearby mountains for grazing. In the evening, he used a stick to collect his cattle back home. One day, he carried an iron stick. While he was beating his stick on the ground, the stick got stuck to a stone. He tried pulling it out and had to apply force to successfully do so. He was surprised. He thought there was some evil spirit in the stick or the rock. The greyish-black rock that was responsible for this was later found to contain a mineral which was named magnetite after the place Magnesia where it was found. Earlier, people called it lodestone. Pieces of such rocks were found to attract each other or repel each other. This naturally occurring material started to be known as magnet. This phenomenon by which magnets attract certain substances is called magnetism. Any substance which has the ability to attract certain substances like iron is called a magnet. Those substances which get attracted by a magnet are called magnetic substances. तो जो भी ऐसा substance जो किसी और मटेरियल को अपनी तरफ अट्रैक्ट करता है उसे मैग्नेट कहते हैं, और वो सब्सटेंसेस जो उसकी तरफ अट्रैक्ट होते हैं उन्हें मैग्नेटिक सब्सटेंसेस कहते हैं. Some such substances are iron, nickel and cobalt. Those substances which do not get attracted by a magnet are called non-magnetic substances. Plastic, rubber, glass, paper, gold, silver, clothes are some such substances. Today, magnet has found many uses in our daily life. Have a look at your pencil box or tiffin box. You might find a magnet there. In some of these boxes, the lid fits tightly because of the presence of a magnet in them. The door of our refrigerator also fits tightly because of the same reason. Some of your toys also might have a piece of magnet present in them. Now we come to types of magnets. Magnets are really fun to play with. Let us know about different types of magnets. So first we will begin with the natural magnets. Lodestone was the natural magnet found occurring naturally in the earth's crust. Lodestone means leading stone. It helped people find their way on land and sea. Then we have artificial magnets. Artificial magnets are those magnets which have been imparted the properties of a magnet by artificial means. Depending upon their uses, they are made into different shapes and sizes. A substance called ferrite is sometimes used to make artificial magnets. It is a mixture of barium oxide and ferric oxide, and it can be used to make very strong magnets. Bar magnet and horseshoe magnet are the most common shapes of magnet, as you can see in this image. An interesting fact here. The earth behaves like a huge bar magnet with its magnetic poles near the geographical north and south poles. The south pole of this bar magnet is near the geographical north pole, whereas the north pole of the bar magnet is near the geographic south pole. If a magnet is freely suspended, it will always come to rest at north-south direction. Now let us look at the properties of a magnet. A magnet attracts magnetic substances. You will find that paper clips and needle cling to a bar magnet with plastic ruler, rubber eraser. Stainless steel spoon do not. Thus, we can conclude that paper clips and needle are magnetic substances, while plastic, rubber and stainless steel are non-magnetic substances. Now, a freely suspended magnet always rests in the north-south direction. The magnetic pull or magnetic influence is strong near the ends of a magnet. These ends are called poles of a magnet. When you suspend a magnet freely, the end pointing towards the geographical north is called the north-seeking pole or north pole, and the other pointing towards the geographical south is called the south-seeking pole or south pole bar magnet. When a bar magnet is rolled in iron powder, you will find that the iron powder clings more to the poles. This clearly shows that magnetic pull is stronger at the poles. Now, poles exist in pairs. If you cut a magnet in smaller part and check their poles by freely suspending each piece of magnet, each will behave as an individual magnet with two poles. Thus, we can say all magnets have north-seeking or south-seeking poles. We can never produce a magnet with a single pole. Hence, magnetic poles exist in pairs. Unlike poles attract and like poles repel. A magnet can attract or repel another magnet. We know that all magnets have north poles and south poles. When two magnets are placed near each other, the opposite poles, north and south, attract or pull each other, and like poles, that is north-north or south-south, repel or push each other. So now we have another activity. Take two bar magnets, suspend one with a thread. You will observe that it comes to rest in the north-south direction. Take the other magnet in your hand and bring its north pole near the north pole of the suspended magnet. You will observe that the north pole of the suspended magnet moves away, that is, repels. Next, bring the south pole of the magnet near the north pole of the suspended magnet. You will observe that it gets attracted towards it. We can conclude that like poles of a magnet repel and unlike poles of a magnet attract. An important fact here. Around 2000 years ago, it was found that a needle stroked with a lodestone, when suspended freely, pointed towards north-south direction. Columbus used this needle during his voyage. In first figure, north pole of one magnet is near the south pole of another. Thus, unlike poles are close to each other, hence they pull each other or attract each other. In the second figure, north pole of one magnet is near the north pole of the other magnet, and south pole of one magnet is near the south pole of the other magnet. In both the conditions, like poles are close to each other, hence they will move away from each other or push each other. अगर नॉर्थ पोल के साथ साउथ पोल होगा सामने तो वो अट्रैक्ट होगा, लेकिन अगर नॉर्थ पोल के सामने नॉर्थ पोल या फिर साउथ पोल के सामने साउथ पोल होगा तो वो एक दूसरे को रिपेल करेंगे. Let us now look at magnetic and non-magnetic substances. Substances which are strongly attracted by a magnet are called magnetic substances. Example, iron, cobalt, nickel, and alloys of carbon and iron. And substances which are not attracted by a magnet are called non-magnetic substances. Example, brass, paper, stone, gold, silver, etc. Let us now look at the poles of a magnet. We observed that the iron fillings stuck mostly near the ends of the magnet. This shows that the power of a magnet is the strongest at its ends. The two ends of the magnet which have a strong magnetic force are called poles of a magnet. There are two poles in every magnet. These are by convention called the North Pole, denoted by a capital N, and the South Pole, denoted by a capital S. The poles of a magnet occur in pairs and cannot be separated even after cutting the magnet into pieces, because each piece will have a North Pole and a South Pole. आप अगर मैग्नेट को बीच में से काट भी देंगे तब भी उसके नॉर्थ और साउथ पोल दोनों पीसेस में होंगे. When two like poles come in contact with each other, they get repelled. This is called repulsion. For example, when the north pole of both magnets come in contact with each other, they repel each other. When two unlike poles come in contact with each other, they attract each other. This is called attraction. For example, North Pole and South Pole attract each other. Let us now look at the magnetic compass. A magnetic compass is a small circular box-like object with a glass over it. A magnetized needle which can rotate freely is fixed inside the box. You can look at this image here. The compass has a circular dial with directions marked on it. Its needle indicates the north-south direction when it is at rest. The north pole of the magnetic needle is usually pointed in a different color for identification. When the compass is kept in the place where we wish to know the direction, the needle starts rotating till its pointed end reaches the north marked on the compass. The compass thus indicates the direction in the place. This property of magnets is extremely useful. In olden times, travelers and sailors carried natural magnets which they suspended with a thread in order to locate directions. Even today, the magnetic compass is widely used to indicate directions. Let us now look at the maglev train. Many countries are using powerful electromagnets to develop high-speed trains called maglev trains. Maglev is the short form of magnetic levitation. Maglev trains float over a guideway using basic principles of magnetism to replace the old steel wheel and track trains. Floating reduces friction and allows the trains to run more efficiently. Let us see handling of magnets now. The following precautions must be taken while using magnets. Magnets lose their magnetic properties of attraction or repulsion if they are heated. Hammers dropped or kept in the east-west direction for long. This process of destroying the magnetic properties of a magnet is called demagnetization. It has been seen that if bar magnets are left free for a long time, they slowly lose their magnetic properties by a process called self-demagnetization. Hence, bar magnets should be stored in pairs in a wooden box, separated by a piece of wood such that their unlike poles face each other. This is done by placing soft iron pieces called magnetic keepers across both the ends. Sometimes a wooden piece also serves the purpose. Horseshoe magnets should be stored with pieces of iron across the poles. Electromagnetic devices should be kept away from strong magnets as they get damaged. Let us now look at the uses of magnets. The magnetic compass, also called the mariner's compass, is used by sailors to find direction in the sea. Television and computer monitors have magnetic strips in their circuits. Magnetic strips are also present in ATM debit and credit cards, which store information of accounts. Magnets are used in electric motors, generators, speakers, and microphones. In floppy disks, hard disks, and audio cassettes, data is recorded on a thin magnetic coating. Magnets are used in making children's toys and other fancy items like stickers. Magnets are used in separating magnetic materials from non-magnetic materials. Magnets are also used in medical diagnosis. For example, MRI, which is the magnetic resonance imaging machine, which gives the image of the internal organs of the body, contains magnets. So let us revise what we have studied in this chapter. Magnets are substances that attract certain materials such as iron and nickel. Magnets are of two types: natural magnets and artificial magnets. Substances which attract a magnet are called magnetic substances. For example, iron, cobalt, etc. Substances which are not attracted by a magnet are called non-magnetic substances. For example, aluminium, stainless steel, etc. The two ends of a magnet where the magnetic force is maximum are called the magnetic poles. Every magnet has two poles. The poles of a magnet occur in pairs and cannot be separated. The end of a freely suspended magnet pointing towards geographical north is called North Pole, and that pointing towards geographical south is called South Pole. A permanent magnet loses its mate if heated or hammered or handled roughly. A magnetic compass is used by sailors to find direction. Like poles of a magnet repel and unlike poles attract each other. Repulsion is the surest test of magnetism. Magnets are found in various appliances like ATM cards, toys, compass, microchips, refrigerators, etc. So, hope the chapter was clear to all of us and we will be able to answer the questions based on this chapter.